Welcome to this explainer. Today, we're going to take an incredibly simple, everyday condiment and transform it into a fascinating scientific protocol. We're going to break down the exact chemistry you need to make perfectly crisp, sweet, and literally glowing pink organic pickled onion rings. We aren't just cooking here today. We are executing what we like to call the acidic allium protocol.
So, I want you to think back for a second. You know that moment when a pungent, raw onion just completely overpowers a delicate dish you're eating? Maybe you ordered a perfect fish taco, or you're eating this carefully balanced salad, and it is entirely ruined by that harsh, lingering onion bite. It's a total culinary tragedy, right? So the big question is, how do you molecularly hack an onion to completely remove that offensive sting, but actually amplify its sweet, complex flavor? And even better, how do you pull that off in just 1 hour?
Well, here is our game plan for this protocol. It's 5 steps. First, the geometry of the cut. Second, thermal defanging the onion. Third, the anthocyanin color shift. Fourth, hot brine versus cold brine. And finally, number 5, avoiding the gray onion.
All right, let's dive right into step 1, the geometry of the cut. For this protocol, we're starting with 2 organic red onions. We use organic to avoid the synthetic sprout-inhibiting chemicals that get applied to conventional root vegetables. We want a completely pure biological canvas for this. Now our goal here is to balance the maximum amount of crunch with rapid flavor absorption. To pull that off, you need to use an equatorial cut. Basically, you're slicing the onion directly across the belly, parallel to your cutting board. Just completely ignore the root to stem axis. You're going for uniform 1/8 inch thick rings, so grabbing a mandoline or a super sharp knife is your best bet here. Once you've got those rings, just separate them and pack them really firmly into a sanitized 1-quart glass mason jar.
And here is the brilliant underlying physics of why we cut it exactly this way. By slicing equatorially, we are severing the onion's vascular bundles at a perfect 90-degree angle. This ruptures the absolute maximum number of cells. Now, the immediate downside to this is that it releases a ton of the lacrimatory factor. That's the gas that makes you cry. But the massive structural advantage is that it completely opens up those cell walls, which allows our pickling brine to penetrate almost instantly.
Okay, moving right along to phase 2, thermal defanging the onion.
So, we've opened up the cellular structure, but now we have to neutralize that harsh, raw bite without turning our precisely cut onion rings to absolute mush. To do this, we formulate what the protocol calls the brine matrix. And guys, this isn't just a random mix of pantry staples. It's highly calculated. We're using 1 cup of organic distilled white vinegar to get that pure, sharp, neutral acidity. Then, we pair that with 1 cup of organic apple cider vinegar for this really complex, fruity depth, plus a cup of filtered water. To balance all that acid out, we dissolve 2 tablespoons of organic cane sugar and 1.5 tablespoons of fine sea salt. And listen, it is absolutely crucial that the salt has 0 iodine or anti-caking agents in it, because those will instantly cloud up your brine. You can also drop in an optional aromatic payload here if you want. Think smashed garlic, black peppercorns, or maybe some red pepper flakes for a little kick.
Once your matrix is assembled, you have to execute the hot pour protocol. Combine all your ingredients in a non-reactive saucepan, something like stainless steel or enamel. You absolutely never want to use aluminum or cast iron for this, because that high acid concentration will literally strip the metal right off the pan and deposit it into your food. Not good. Bring the entire mixture to a vigorous rolling boil. That high heat is totally critical. The very second it reaches a rolling boil, you pour it directly over those raw onion rings packed inside your mason jar.
So why do we do this? The crucial point is understanding exactly what that boiling acid is doing on a molecular level. It is instantly denaturing the alliinase enzyme in the raw onion. Now, alliinase is the protein that's responsible for producing thiosulfonates. Those are the harsh, burning sulfur compounds that just completely overpower your palate. By denaturing this enzyme instantly with that high heat, we permanently halt the production of those compounds. It leaves literally nothing but the sweet, complex allium flavor behind. It's honestly a game changer.
Which brings us to phase 3, the anthocyanin color shift. This step is for sure the visual climax of our whole experiment. When that hot acetic acid from the vinegar matrix hits the onions, it forcefully lowers the environment's pH. Specifically, we're looking to drop the pH right below the 3.0 threshold. And you might be wondering, why does this exact number matter? Well, it all has to do with the purple pigments naturally existing in the outer layers of the red onion. Those purple pigments are called anthocyanins. When the pH drops below 3.0, these anthocyanin molecules actually gain a proton. This structural change radically alters the way the molecules absorb light. So, within literally just 10 to 15 minutes of the hot acid hitting those onions, you will watch them physically shift from a dark, muddy purple into this brilliant, translucent neon pink. It is rapid, edible chemistry happening right on your countertop.
Let's tackle Section 4, hot brine versus cold brine.
So let's address a pretty major culinary debate here. Pickling purists out there will frequently argue against the hot pour. And to be fair, they correctly point out that pouring boiling brine over raw onions does slightly cook them, which costs you about 10 to 15% of the vegetable's raw crunch. So they advocate for a cold brine pour to maximize that texture. But let's actually look at the science. A cold brine utterly fails to denature that alliinase enzyme we just talked about. Because of that, cold brined onions retain a super harsh, kind of burpy, raw onion flavor. Furthermore, a cold brine takes 48 long hours to penetrate the cell walls of the onion rings, whereas our hot brining method takes exactly 1 hour. Sacrificing 10% of your crunch is scientifically and, let's face it, gastronomically, totally worth it for the massive improvement in flavor and efficiency.
And finally, Step 5, avoiding the gray onion. Once your hot liquid is in the jar, give it a few firm taps on the counter to dislodge any trapped air bubbles and make sure those rings are entirely submerged. But I really need to issue a serious warning here about a potential chemical failure that can ruin your entire protocol. We call this the gray failure. If you use standard tap water that's heavily treated with hard minerals, we're talking calcium or magnesium, or if it contains alkaline compounds, those minerals will actually buffer the acidity of your vinegar matrix. And if the acidity gets buffered, the pH simple will not drop below that magical 3.0 mark. Without that drop, the anthocyanins don't gain a proton. And instead of a brilliant neon pink, your onions are going to turn into a sad, totally unappetizing gray or blue mess. And this is exactly why you absolutely must follow the protocol and use strictly filtered or distilled water.
Once you've successfully navigated the matrix, just leave the uncovered jar sitting out at room temperature for an hour to cool down safely, then seal it up tightly and move it right into the refrigerator. Thanks to that equatorial cut and the thermal defanging, they're actually ready to eat in exactly 1 hour. Though, to be totally fair, they reach their absolute peak flavor equilibrium at about the 24-hour mark, and they'll keep nicely for up to 3 weeks. You have now officially mastered the acetic allium protocol. But I want to leave you with this thought today. Knowing just how simple it is to manipulate enzymes and cellular structures with everyday acids and heat, what other vegetables will you hack in your kitchen laboratory? The possibilities are honestly endless. Thank you so much for joining me for this explainer. I hope you take this knowledge and use it to make something incredible.